Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're gonna take a look at Kessler syndrome. So let's dive right into it. So what it is basically space junk. Now, were we littering in the space? Yes and no. Now simply think of it this way: if when we send rockets, specifically 3-stage or more stage rockets, the upper stage generally does not fall back to Earth, so we end up with giant rocket stage that is orbiting. So in this sort of scenario they act as a junk basically, because there is no purpose in this. It's not serving any function, it's just there. So that orbit where it's orbiting, it's flat out useless for any other satellite. So, and when you have something like this big, it also has the consequence that because solar radiation is much more intense at those altitudes, as in few thousand kilometers, the paint from these puppies peel off. Now you might be like, okay, paint should not cause any issue. It does cause an issue simply because if even a small gram to milligram of a paint fleck travels at 24,000 to 29,000 kilometers per hour, is gonna cause severe damage to your spacecraft. Now the fact that it is small and the fact that it's super high speed should only means one thing: destruction. Because this even though mass is so small, the kinetic energy per gram is so damn high that if you get hit by something, let's say 10 gram, or even like something as small as a nut bolt, yeah, it's gonna destroy your satellite. So for this reason this started to become an issue. Like first we had a large rocket, and not to mention when we have solid rocket boosters, SRBs, basically the exhaust also has particles in them, basically aluminum particles, so they also become an issue. So it's very small and it's a very high speed, and we generally have radar stations on ground to track it. However, there is a category that we can't accurately track because it's too small. So those too small is generally below 10 centimeters. So if anything is below 10 centimeter, at best case scenario, if the density is too damn high, we will detect there is this cloud sort of situation happening, but we will not able to predict how many things are there in that orbit. So when you talk about things of that nature, something smaller than 10 centimeter, which can still cause significant damage to satellite and space stations, there are millions of them. That's where the problem comes in. It's not like there are just few big ones. If we had things like that, it's not an issue, but because we have millions of them, it's an issue. So what is this Kessler syndrome then? That is space junk. So what is the Kessler syndrome? It's after a professor. The name is after a professor. Basically he came up with the idea that we could have a scenario where we have a crash. Inevitably, sooner or later, things crash into one another, which has happened in 2009 when Cosmos, a defunct satellite from Russia, 2022-51, crashed into Iridium satellite constellation 33. So what could happen? Worst case scenario, the Kessler syndrome, the runaway, is basically you will have one crash. So this happened in 2009. That created that many debris. Now we were lucky this were in generally lower orbits, but if it would have happened in higher orbit, it would have created this. Basically you will have one crash which will lead to many more crash, that will lead to even more crash, and the whole space will be just littered by debris. This was the premise of the movie Gravity. So it's not a far out idea, it's not doomsday scenario, it's a mathematical scenario. It's like if you have one crack in your dam, nothing happens. If you have 15-16, yeah, your dam needs maintenance quickly, otherwise it will crack. So breakdown, things of that nature happens in space also. It's like you have one object causing a collision, okay, no problem, but if it creates debris that is causing collision with 100 more, yeah, then the chain reaction is like a nuclear reaction, 1 to 10 to 100 to million. So in that sort of scenario, we'll have space debris that will cause more debris, and then we'll end up with a scenario where we'll have no space. Now be mindful, when I'm saying no space, it's not that this whole area will be littered that we can't see through it. It will be invisible to us, but because there will be so many small particles traveling so fast, any rocket trying to go through it will get destroyed by it. That's the fear aspect of it. It's not that we can't build something that can withstand it. It's just that instead of sending satellites that are, let's say, 1 or 2 tons, we have to send satellite with an armor of 60 or 80 tons. So suffice to say, practically we cannot do that. That's the fear. The fear aspect is that once this chain reaction has begun, there would be no ability to launch anything. We can't go through it, because even though we can track big process, once enough of them have broken down into small pieces, it simply would be untrackable. It's like you can track one giant whale, but you can't track hundreds of small microbes. That scenario would occur. So even though there would be a lot of space in space, it just would be too dangerous to do anything. That's the Kessler syndrome. Basically we'll be trapped on Earth. So you might be like, okay, I don't care, like it's space, I don't care, it's how it's gonna affect me. Well, let's start with the simplest and the first one sign of it. There will be no satellite navigation for terrestrial and aviation use. Now you might be like, I don't use GPS. Again, you may not, but every delivery service does rely on it. Ambulances rely on it, like taxi services, Uber, Ola, all of them relies on that. So it is a big part of terrestrial world that we are relying on satellite navigation. And when I say satellite navigation, I'm not meaning only GPS. There is GPS, there is GLONASS, there is Navic, there is G3 structure. There are hundreds of things. All of them give us a very good accurate accuracy on navigation. And not to mention, even though you can like let go of terrestrial use, what you gonna do with aviation? Now, before the advent of GPS, planes used to rely on what we call internal navigation system, and they were very, very prone to error. Sometimes plane could drift upwards of 100 kilometers, like it's going in a straight line, but like navigation does kind of drift over time. GPS, because it can keep checking, internal navigation cannot check from anything else, it's not getting any data. So while it's going overseas, you could have a scenario that you can be off by like 100 or 200 kilometers. Things of that nature has happened where military fired on a civilian airline, not knowing that civilian airline is here in the restricted territory, not because like they wanted to crash or cause any accident, they simply their navigation drifted. So for our current avionics, basically we need GPS. We can't use this many plane in our airports if we don't have GPS, GLONASS, and hundreds of other systems like that. So even though we can like litter the whole land with radar stations to balance it, what you're gonna do on sea? So we need like your airport done. If GPS goes down, if GLONASS goes down, if all navigation goes down, yeah, your airport, they have to reduce the number of planes that is going back and forth. That you may say like, I'm poor, I don't care, but you will be affected by the fact that there will be no direct to home TV. Now that itself may not be an issue, but because television is a big communication industry, like data from point A to point B gets across using it, that's a big blow to any civilization and any society, and news network will collapse, basically all of them, not one or two, all of them. And then we'll come to the long-term consequence of that. There will be no weather forecast. Now you'll be like, okay, weather forecasts are not reliable. They are. When I used to be young, basically, in 10 years old, I remember seeing basically satellite predictions of where the hurricanes will go. Those were very inaccurate at that time. That time they were like giving accuracies in such a way that it was like, okay, this whole coast area is in danger. Like hurricane is coming from this side, this whole coast area is in danger. Nowadays we are so good with our predicting ability that like now we tell that this state, this district, it's gonna hit land, and we are accurate to it. Like if you see the accuracy, how accurately we are tracking our weather phenomena, especially large weather phenomena, it's creepy how accurate we are in predicting those things. They may look unpredictable, but we are like, yeah, it's gonna go here, go here, go here, go here, and touch land here. Yeah, it does touch land there. So imagine going back to a world where you have no early warning system, you have no scenario where you can actually know what kind of hurricanes or tsunamis is happening. So the weather is also out. Now again, you may still say, I don't live around coast, it's not going to affect me, but the final key will affect 100% of individual on this planet is the fact that it will crash stock market. Basically money will lose its value. Now I'm not going to go in detail like how many steps will have to happen if that happens, but suffice to say, it's very dangerous, and if money goes, everything goes. So for this reason, Kessler syndrome is truly a danger to you and I. It's not something like, okay, only affect rich people or self-driving car. No, it's gonna affect 100% of us. So it is a big and absolute danger. So what's being done about it? Now recently, once people started to understand this, that Kessler syndrome is an inevitability, not like oh, it may happen. Like as more and more and more and more rockets started to be launched, people realized that it's not a point of whether it could happen or not, it's like when it will happen. So new laws were passed in around 2000 and 2002 that any new satellite built after that period must have a way to dispose of it. Basically, if it's a geostationary satellite, there should be a way to send it to graveyard orbit. If it's a low Earth satellite, it should be able to devour orbit itself properly. So that's a now mandatory law. Now be mindful, it's not applied on every country, and it's not mandatory as in like no like somebody is holding a gun to you that you should do it. It's not like taxes. So there have been some laws that has been passed, and European Union, France and USA I think is taking this law seriously. Now effort from all manufacturers, be it ULA, be it from SpaceX, be it ISRO, from all areas, the effort is to reduce now. That's the whole point. Like, we don't want to send anything in space that will cause more catastrophe. So response has been there. Like, it's not like the people in charge is like sleeping. They know what is going on and they are taking steps. Now, to help with our current situation, we have what we call tracking and monitoring stations, things of this nature, basically littered around the globe, where it's tracking and communicating with on multiple ground stations to give a very accurate prediction when the collision is gonna happen, how to avoid it, what kind of things we can do. Now, be mindful, even though we are tracking it, sometimes we end up in a scenario that two satellites that are active may be low on fuel or maybe out of fuel. In that scenario, we will simply wait and watch how that clash happens. So it's not that even if you can predict it, you may not be in a scenario where you can do anything about it. It's like, let's say you are seeing that there are 3-4 satellites that are gonna make a close call with a giant second stage. Let's say you moved one satellite, it had fuel, you moved it. What about the second one? What about the third one? So things of this nature. So this is a very stopgap measure. It's like we started this very early on, and we are taking a very closer look with it. So a lot of money is being spent into tracking and monitoring, so at least International Space Station remains safe. Then all these countries, be it European Union, be it America, be it DARPA, they are taking this enough seriously that a lot of R&D money has started. Like, at this point, DARPA is asking for the world, like, hey, do you have a solution to this? So there are some solutions that are being brought to the table. Now, you may be like, okay, if it is this serious, like this kind of response is very, weak response. It's like, let's take care of it. It's like, now you have to understand the problem with this is the politics and money. Now, money, I will explain this very simply in this way, is that you have to go to someone and say, give me billions of dollars so I can clean junk. Yeah, that's really not a very strong pitch meeting. Nobody cares, like, unless that Kessler syndrome happens, nobody's gonna care about it. It's like global warming, nobody gonna care about it unless it happens, unless, like, we really start to see sea level rising such a rapid rate that small islands to go away and coastline starts to go. Only then people will be like, okay, we have to take this thing seriously. So that happening with the money is like, you can't go to ISRO or you can't go to NASA or ESA where, like, okay, spend $1 billion to clean up space jam. Nobody's going to give you money for that. Try selling it to audience, try selling it to your public. And then it comes to the fact that there are some lot of ground-based solution, that like space gun, laser broom, and high explosives in high orbit. Not orbit as in low altitudes. Is that the problem with that? These things, even though they can clear a lot of space junk, they can also clear working satellites. Now that creates a political nightmare. It's like, think of it this way, let's say China builds a giant space laser and it's like clearing its debris. Now either by accident or by just some happenstance happens that India also loses one satellite that is in that area, that affected area. Now what will India think? India will think that China used a laser weapon to disable our satellite. So you can understand that, like, nobody wants this lasers targeting their satellite, but we have to do it. Sooner or later we have to do it. So there is a lot of politics involved into this. Nobody, even though ISRO have good intention, even though NASA has good intention, even though ESA has good intention, nobody can honestly do anything about it, simply because it's any weapon that will allow you to clean those things can also allow you to knock down active satellites. For this reason, it's very intermingled. However, even though with all those doom and gloom scenario, I want to state one thing very obviously for in front of you, that it can be done. We can take care of it. It's like, if tomorrow this happens, if, like, okay, let's say one meteoroid hit one big geostationary satellite and this Kessler syndrome happened, we can take care of it. It's like, if this happened, like if truly that happened, we can take care of it. We will be back to our working order in less than 50 years. We have the technology to take care of it. Like, first technology is giant guns. Now this is hard project. There has been a Babylon gun which is much bigger than this. So this sort of gun can simply knock out things in from orbit. Now you're already like, wouldn't this itself introduce more? No, simply because it's not meant to fire things on orbit. Guns do not allow you to do that. Guns simply fire something in what we call ballistic orbit. So it will go up and it will fall back, no matter how fast you throw it. Now, if you fire it, let's say 100 kilometers per second, of course it's gonna leave Earth, but it's not gonna come back. So you cannot introduce things using this. Now you might be like, doesn't this gun is a danger to safety? Well, no, simply because it is going to be so big you can't aim it, and once you built it, everybody knows where it is. Everybody knows, like, you know, if you try to use this sort of gun to attack some other country, everybody knows where to attack. This is like worst weapon, but it can allow you to very cheaply use explosive and just you know, bombard the whole orbit with enough projectiles that either while they are going up, like, because it's orbit like this, it's going up, it can knock things out, or it will, like, while coming down, it will knock things down. In that scenario, it can clear up a lot of area. This is a gun approach. This is, you know, old Western approach. Then we have laser broom. Of course, like, right now this is the simplest and cheapest option, but problem is you are talking about lasers that are powerful enough, like they can have pulse of a few megawatts per second, not second as in picoseconds. So the pulse that can go through, so generally they are built in high altitude places, as in mountain tops, so they can go through atmosphere without losing enough of energy. Or you can have like hundreds of them, which is you know, giving less energy, but they are all focusing on one point. That way you can deorbit even big objects. Basically, the moment you hit something, the laser will hit something, it will evaporate that area. That will act as a thrust. So if you have a giant rocket stage coming up, you fire a laser pulse into this and it evaporated, it will slow it down. So generally things will fall to earth no matter what you do. It's like, the only problem is it will take 500 years. So using this method, you can reduce the time to like few minutes. It's like, okay, now it's deorbiting, 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 deorbiting. So, and there is another NASA proposal. This one is the kind of funny proposal. I have provided the link down below. Is basically they're gonna have high altitude balloons, nothing fancy, just simple balloon with giant explosives. Now that explosive is not nuclear, it's normal explosive. They're gonna go to high altitude and they're gonna pulse blast it, as in detonate it as quickly as possible. So it's gonna throw a column of air upwards. Now anything that is caught into that air, you know, air, basically shock wave, it's going to lose its speed and fall to orbit. So they predicted that it will allow to clear up low Earth orbit in few days. So we have solutions at this point, flat out. We have the tools, hundreds of tools. Like this gun was decommissioned, we can build it in, like, say 1 year. And like big ones, this already lot of what you say observatory are at this position with lasers that are powerful enough. So a lot of these sort of scenario, we have it, like the tools are there. It's just that until Kessler syndrome really becomes an issue, nobody's gonna take any action on it. So this is the, you know, stalemate that we are in right now. So it's not hopeless. Be mindful of that. It's not hopeless. We can take care of it. It's just everybody is waiting. So this was my presentation on Kessler syndrome. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it. You can dislike it. I would urge you to leave a comment on my video, and please share it amongst your friends. #RocketMonday, and subscribe. Press the bell icon if you're free. And as always, thanks for watching.